Thanks, Alekia. Hope I am audible well. Just doing a quick check. Am I audible, right?
Yes, sir, you're audible.
Yeah, thank you. Yeah. So before we start, just to give you a brief about the topic today. So what we will try to cover today is basically about, you can probably do a control L, whoever is doing that, and that would go for. So today we will discuss a bit about sustainability, a lot about AI and how they go together. Because of late, as you all might have heard, the term AI, it has both negative as well as positive connotations to it. But today we will discuss about the aspects of AI that can actually drive sustainability. So when I talk about sustainability, typically we talk about the entire gamut from the ESG perspective, which is both all economic, social, as well as governance. So if I can go to the next slide, please, wherein we have the content. Yeah. So we would start with the typical goals. As you know, there are certain 17 sustainability development goals that we aim for, right? So we will talk about those sustainability goals. We'll talk about some immediate deadlines. Well, most of the deadlines are probably uh, a bit around our carbon footprint and how we manage it, how we do it better, etc., etc. But there are some leading goals that we'll just touch upon, and then we will delve into how AI as a technology can help us attain some of these goals or help us achieve some of these goals, right? And well, AI does not come free. AI, there's also a duality question in AI. What I mean by that, even to do things with AI, even to train the models that we talk about, even to use the compute capacity that a typical AI kind of solution needs, it also has its own carbon footprint that it kind of imparts. So there is a fine line between what to use and what not to use, how much to use. So we will discuss a bit about that aspect of it. And finally, we will talk about, is AI all about being good? Is there some economic aspects of it? And if yes, what are those economic aspects and what are the prospects around AI? So that is how we would typically shape up this discussion. So I would roughly take around 40-45 minutes to do that. And then if there is interest and questions, we will try to see if we can attend some of the questions. I will try my best to answer all that I could. And in case there is something that I'm not able to handle today, I am more than happy to get back with those relevant details as required. So without wasting any more time, let's go to the next slide, please, wherein we talk about the sustainability goals. So there are 17 goals that we talk about, right? When we talk about sustainability. And as I said, sustainability is just not about climate, just not about greenhouse gases, just not about your carbon footprint. It has a bigger aspect around it. So when I talk about bigger aspect, this is how typically the sustainability goals are categorized into. So we can see 6 groups, wherein we have the first one, which is reduction of inequality. So to make a holistic sustainable environment, it's important that we have uh, equality within the system, and for that we have certain goals, as you can see, like no poverty, zero hunger, reduced inequalities, that is removal of bias, and all those aspects. Then we talk about safety, wherein we say that anything has to be sustainable, it has to be safe. And for safety, we have to have good health, we have to have good water, we have to have access to clean energy, and on top of all of this, there should be a certain amount of affordability so that it's available to one and all, and hence it's sustainable. Then we talk about growth. When we talk about growth, obviously we talk about how that has to be sustained, whether how we can maintain peace and harmony while we are doing it, how do we have our industry innovations and infrastructures scaling up without harming the society in general, the environment in general, and obviously how do we have a economic goal which is not too aggressive, not too regressive, it's in the right amount so that it's sustainable and it goes on for a long time. Then we talk about equality, education, a bit about sustainability partnership, because we have to drive sustainability. There has to be certain partnerships that are in focus. And finally, climate action. Probably many of us kind of correlate between sustainability and climate action because that is probably the most talked about thing. And some of the deadlines that I will discuss are also probably in some way related to the climate action, which talks about how do I maintain my carbon footprint, what do I need to do so that I stay within my threshold, right? Overall, what we are trying to say is the sustainability is not something that is optional today, but it's something that is absolutely necessary because at the end of the day, we have one planet, one ecosystem, and that pale blue dot that we have to save, right? So if we can go to the next slide, please, where we talk about the deadlines. So some of these deadlines you are more or less aware of. So one is about the 1.5 degree limit. So the Paris Agreement states that we should keep the global warming post industrialization something below 2 degrees. And most preferably it should be somewhere around 1.5 degrees. So that is one of the critical aspects that we are kind of chasing. And to do that, obviously there are aspects around how do I reduce the global warming and hence probably my carbon footprint, and hence how do I define my system, what I use, what I don't use, the entire part of it. Because once we cross this threshold, it is difficult and in some cases irreversible to go back, right? So hence that is something that we have to keep in mind. And to do that, we have to do a 43% reduction in our emission by 2030, which is quite a lot, to be honest. But again, that is something that we probably have to uh, aim or have to achieve, right? So that is around 43% reduction in our greenhouse gases emissions that we have to attain. And also by 2050 we have to do a net zero kind of get into a net zero kind of situation, which means that the amount of carbon that I am impacting or creating, I should be able to balance it with my carbon credits that I have. So carbon credit is again a very different aspect, but what we are trying to say is that the way you should run your business, define your business by 2050, you should not be adding on to anything, any more net carbon into the system. And if you are adding at a holistic ecosystem level, you have to compensate it by either buying credits or doing activities that gives credit, so that whatever you are kind of emanating into society, into the ecosystem, is counterbalanced. So these are some of the core or objectives, if you can say, mostly from a climate perspective. But again, these are some of the things that we are chasing. Now, to do that, how is AI helpful? So AI as a what is, first of all, let's speak a bit about AI. See, AI is something that is not new. It has been around for quite some time. But the more that you are hearing nowadays, the proliferation of AI that has come up is probably because one of the critical aspects that has become possible is our access to the infrastructure to run the AI. AI was already always there in the system as a concept. Everybody, many of us knew about it, but it was very costly to run real big AI computations and logics, etc. Right now, what changed this is the access to the infrastructure that we have today in terms of hyperscalers, clouds, etc., which made it very easy for most of the people or many of the people to get access to the relevant infrastructure and hence run those algorithms and solutions and code bases so that we can enable AI. Now, one of the very important aspects, one of the few, or rather few of the aspects that AI probably touches upon from a sustainability perspective is energy optimization. One of the major reasons for our carbon footprint is how we consume, utilize, and work with the energy system that we are interacting with. So with AI, we can actually have a very optimized kind of an environment or smart grids, as we call them. Because today, when we talk about energy, right, it's not only about generating energy. Now, consumers have become prosumers, which means that I generate some, I consume some. I might have a solar panel on my roof, and hence I am giving back to the grid. Or I might have a farm wherein I have windmills or wind turbines kind of things installed, and hence I am able to give back to the grid. So the way energy is consumed today is bidirectional rather than one directional from the grid perspective, and hence the it's very important to optimize how I distribute my energy so that I get the maximum utility from the energy without creating a footprint that is big enough, or rather optimize my footprint. So that is something that can be done around smart grids, around intelligent grid, intelligent energy generation, which is a combination of what you do from coal, what you do from oil, and what you do from solar or maybe wind. Agriculture, the way agriculture is being done, the kind of fertilizers that we are using, the kind of yield that I am getting from my field, etc., all that can be very effectively monitored and optimized, so that I again have the objective of having a very sustainable kind of environment wherein I use only what is required, so that I produce what is sufficient, right? So the imbalance of let's say over usage of fertilizer, over usage of water, or wastage, if I have to say, that has to be minimized. Similarly, talking about wastage, we talk about circular economy, wherein we talk about promotion of reuse, we talk about limiting of wastes, and that can be very, what I would say, very example very close to us is typically restaurants, right? Most of these large restaurants that you see typically waste around 20 to 30% of the food that they prepare. Why? Because they are not able to judge how much would be the demand, or they are not effectively able to judge the demand, right? And if they are true to the business, they would probably not sell the produce that was done earlier the next day. So there are solutions as granular as that, which has been developed to see that the wastage in general is at the least, so that my demand management is effective. I create just enough that I can consume or sell, and that is, I took the example of a restaurant, for example, but that can be extended to many other areas as well. Finally, climate modeling, a very important aspect wherein we talk about how the climate is going to be there, or how the climate is changing, what kind of weather conditions will happen, what is my predictions, what is my forecast, and hence how do I save lives, right? If I am able to predict weather, by the way, is one of the most complex things to determine and predict, because the parameters, the variabilities are huge. The way it reacts is probably until today, even today, it's very unpredictable in that way. Now with this with the ability of AI, with those super powered LLMs, etc., we are able to predict weather to a certain extent. We are able to and hence we are able to save lives, save property, and again bring in more sustainability. And finally, even in the biodiversity space, right? We know about let's say certain species. Let's say, for example, the killer whales, right? The orcas. Of late there was a situation wherein their population was going down significantly. So it needed monitoring, as well as a mapping of their movements, their environment, and all that aspects. Initially it was very difficult to do it, in terms of who will go, how will you monitor, how will you know how many species are there, how will you map them, etc. But with the advent of computer vision and the AI brain behind it, all those things have become relevant, relatively easy, in terms of I can, let's take a forest scenario, for example. I can actually have automated cameras installed at critical junctures, or critical points within the forest, and very easily be able to count the instances of a certain species, able to get that data, able to map that to a system, and get a better understanding of how my biodiversity or how my biosphere is reacting and changing. Things which were not so easy earlier, was a bit difficult, but with the advent of AI and the capabilities that AI bring in with the advent of drones and other flying or as we say air surveillance systems that we have, many of these things are today possible, right? And behind all this is probably the models and the brainchild that is the brain that is the AI. And obviously running AI. Now we talked about all the good things that AI can do, but does it come free? No. Even AI, to run those models, to train those models, to fine tune those models, that requires a lot of energy. So and since you require energy, you are by by that perspective again creating a larger footprint in terms of your carbon footprint. So one of the PwC reports of 2024 stated that AI can actually reduce the greenhouse emission by 4%, that is by 2030. But at the same time, we will see in a few slides later, AI by itself, training an AI model, hosting the AI compute layer equivalent, also has a certain impact on that. But net, what is being seen or being envisioned, that AI can probably save more than what it creates as an impact. So that's how we see AI in the parlance of sustainability. Next slide, please. So which are those flavors of AI? Now, when I talk about AI is a very broad term. So there are different aspects that AI bring in, and these different aspects are effective in different areas of sustainability. When we talk about machine learning, for example, predictive modeling, pattern recognition, optimization, all of this is actually focused towards or directed towards resource management, which means that I use my resources effectively. I am able to deliver whatever is required in a very optimal way with the minimum amount of footprint, and hence improving my sustainability quotient. Similarly, when we talk about deep learning, wherein the neural networks, etc., of the world come in, which is for complex data analysis, right? Which means, for example, climate modeling, very complex system, too many variables that has to be dealt with, and all that has to be seamlessly integrated, and then we can actually create a model which is able to predict my climate tomorrow or my weather tomorrow, or how things will shape up in coming 5 days, 7 days, so that I can plan accordingly. Maybe there is a cyclone warning or a possible cyclone, so how do I take the different measures so that I can save life and property both. Then we talk about natural language processing, wherein while sustainability execution is one part of it, the other part of it is about the policies, the reporting, and the changes. Now, in today's world, many of the things are very automated in nature, and these are all evolving areas. So rules and regulations keep changing. So with AI, and it's very easy because it's like somebody reading through all the documents, reading through all the contents that are there in the world, and predefining or kind of automatically defining my stance to that. Initially, it was very difficult to do it, but with natural language processing capabilities, parallel processing capabilities, we are able to do it very quickly and in a very automated fashion. Wherein even if you don't execute the entire strategy, any changes from regulations perspective, from research paper perspective, etc., easily consumed, and that are at the tip of the fingers for the administrators or whoever are the decision takers to take a very well equipped or a well educated decision. So that is something that natural language is doing. Computer vision, we talked about, is a very interesting case of computer vision. Um, uh, we know about deforestation, right? Deforestation, most of the situation, what happened was that in case of illegal felling of trees, illegal deforestation, we came to know about it only when the event has been done, right? Now, with the advent of computer vision, with the advent of satellite imagery, real-time analysis, all this to a certain extent is can be detected real time, because if I have a satellite image which is feeding into my AI models, a live feed, it can be analyzed dynamically to show whether there is some amount of substantial amount of deforestation happening in any area, and that can raise the alarms as required, and that can be a very seamless and a very effective way of addressing things as and when it happens, rather than having a post occurrence kind of strategy and a view which was there till today. Finally, we talk about generative AI. Again, a very talked about space. A lot of literature going around. Everybody of you, or most of you, might have interacted with it. Now, how generative AI today is helping is that earlier we use to envision something, right? How it would look like, or what it would be, what would be the strength of that particular material, or what would be the strength of the particular construction. More often than not, we had to create POC, or we have to really go ahead and create that item. We have to do those kind of testing. Now with generative AI and advanced generative capabilities, we have something known as the digital twin equivalent, wherein I need not create my not approved design at the experimentation phase. I can look at different designs. I can do all sorts of testing that is possible on those designs. Have a shortlisted a number of designs so that I don't create 50 demos and 50 individual POCs and then select one of them and waste other 49. Now that 50 can be easily reduced to 5 or 10. So that saves me that saves a wastage of around 40 kind of designs which probably needed a POC to be done. So those kind of things are already in place. And finally, we are talking about taking this AI capability at the edge. What I mean by at the edge is at the device level, and therein comes in the concepts of smart cities. Now, when you in many of the cities, for example, Singapore, for example, Dubai, for example, there is this concept of smart city wherein you have many public amenities which is smart enough to give some indications or give some what I would say announcements that would be used by the citizens, right? So it might be something around your desert storm coming up, or some weather conditions. It can be as good as your parking availability and all that. We see it at probably every juncture of our life, if not outside India, even as well as outside India, and also within India in certain places. So those kind of things are also becoming very popular. So what is behind that is the brain associated with it is from AI, and the interpretations or the manifestations of that can be several, as we can see here. Next slide. So I have taken a few use cases. I will just try to touch upon them, right? Wherein we talk about how we talked about machine learning, right? Now we talked about machine learning, and from a sustainability perspective, we know about climate actions. So how do you think, or what are those real life examples wherein machine learning is being used to drive or enable climate action related sustainability? So, for example, Google's data center. Data center, as you know today, is are those entities which is basically ruling your entire compute layer. So everybody is going to cloud, but cloud does not come just like that, right? Behind cloud, at the end of the day, there is some infrastructure hosted in some data center. Now, these data centers are huge establishments which is very power hungry and has a lot of power requirements, right? Now, at the same time, there is also cooling requirements that are required for this data center so that they can manage, they can run effectively, and there is no hazard, etc., etc. So to do that, what Google did, it used its algorithms, or the ML, machine learning models, which talks about reinforcement learning and those other details of it, which was effectively able to manage the cooling system so that I use only that amount of cooling, or to that I cool it to that extent which is required at that point of time, which has a lot of parameters. If my weather is cool outside, I might not require as much cooling as it was required on a warm or a sunny day. But as of date, either those activities was not enough automated or not enough effective. Now with AI reinforcement learning, which talks about the real-time feedback, etc., I can manage this entire thing of what would be my cooling, not only on weather, but also on the load, because the number of servers that are kicking up because people are using more, or my entire ecosystem is using more, that also has to be integrated with the cooling system. So it's a very complex algorithm, if I have to look at it, there is the input from weather data, there is input from my IT load, there is input from the kind of devices that are being used. There can be even further inputs in terms of what is my emission scope, in terms of what kind of energy I am using today. There are, as you might be aware, there is scope 1, scope 2, and scope 3 kind of carbon footprint that we talk about. So even the kind of energy that I am using is also being tracked, which means that am I using a hydro energy? Am I using a energy that is from a power plant, which is coal or oil, for that example, or am I using solar or wind or something which is more sustainable in nature? So, and today, as I said, when I talk about smart grids, the energy that is being circulated at a certain point of time also has a metadata allotted to it, if I have to say so, whether it's it's being from fuel, or from air, or from hydel, etc., etc. So I have to also I can go to the extent of saying that I will use maximum energy when the energy is being supplied from a sustainable sources. So, and hence you have even zones which this typical cloud operators are operating out of, which are driven by sustainable sources. So those are the zones that they are promoting. And if you provision your equipment or your infrastructure in that zone, you get a preferential pricing compared to other zones, so as to promote that. So all those kind of nitty-gritties are built in, right? So that's around the data center. Similarly, IBM had this Green Horizon project, which is exactly again related to the energy mix, which stated that if I have to have I have to supply something to the grid, how do I effectively manage my mix? Up to which point do I drive from my fossil fuel enabled power plants? How do I switch over from that to wind? And if I see the wind is not good enough, how do I switch over to solar? Or even how do I switch over to my battery power system, so that I have a seamless output to the grid? But I optimize my generation in such a way so that I have a minimum footprint on my environment, using which by the way is created. The footprint is more if I use fossil fuels equivalent. So that is something that also needs to be taken care of. Next slide. All right, I touched upon it. Microsoft's AI for Earth, which is basically again based on a CNN model, and this was around underwater sightings of orca, which is a kind of killer whales, because this was an endangered species, right? There was a requirement to track how many of them are there, which are the traffic shipping traffic impact that it might create, and hence how the rerouting of my traffic would happen. Now, again, a very, very complex scenario, which means that I have to have a device or a system equivalent which is able to detect orca, and once it's able to detect the position, the geo position of it, it's able to report, and accordingly I have to reroute my shipping routes or change my shipping routes, and all of this has to be done with the ultimate point of or ultimate objective of minimizing my carbon footprint and saving my biodiversity. So if it is an endangered species, I don't want to harm it or hamper their ways of living. At the same time, I have to manage my shipping lines, limit my usage in terms of carbon footprint. So all this entire ecosystem is something that was being done by this project from Microsoft's AI for Earth, again powered by neural networks and some of the OpenAI models, which was being done. Similarly, we were talking about the climate change, wherein we have discussed about it. It's about understanding how the weather would change, or how the weather would be 14 years, 14 days, 15 days down the line, so that I can have my entire planning mechanism to actually save both in terms of property as well as life, right? So that's the early warning system that has been defined, again, primarily on transformer based models. So these are several models that we talked about. We might not get deep into what these models are, what they're capable of. A lot of text is there, and mostly it's maybe a bit more technical to discuss that. But the point here is that all this is happening this because this data was available, right? But the capability to process this data effectively and quickly enough was probably not available with us, and that is what AI today is enabling us to do. Next slide. Natural language processing, we talked about this. One of the aspects, social, right? We have probably talked a bit about the economic and then the climate and that's the environment perspective of it, right? Social perspective. What is happening today? Social media is a very important tool. It is making and breaking social fabric in some ways, right? It can lead to a mass movement. It can lead to a very big what I would call as a propaganda war and all that sorts of things. So how exactly do I manage my social media? How do I predict what is happening in social media? And as you know, social media, there are so many millions and millions of users, in fact billions of users who are using social media all the time. And I'm sure as we are talking about this, discussing on this topic, there would be many who are probably checking their WhatsApp, publishing something on net, doing something on somewhere. So all these things has to be effectively tracked, right? And again, tracking that means again a very big exercise in terms of managing the data, streaming data, analyzing the sentiments around it. So sentiment analysis, topic modeling is something that is also coming to be very important, and hence social media mining in terms of understanding which are the groups, or which are those areas, or which are those pockets of the society that needs to be addressed, what is happening where, and what kind of from a sustainability perspective, again, what kind of action that needs to be done, so that I don't it does not lead to something that is counterproductive in nature from an economic, social, or even climatic perspective, right? For example, there might be a situation, just to take this to life. There might be a situation wherein maybe a group of individuals are discussing about something of an upcoming forest trip, and within that, maybe a few guys or a few people are discussing something around sandalwood, or something around some indications around what they want to do after they go to the forest, or any kind of poaching activity that they want to carry out. And this might be even subtle hints, not direct disclaimer saying that this is what I want to do. There might be some subtle hints that are there. So how effectively I can monitor this data, analyze the sentiment, and understand what is going to happen. It's more like the Minority Report, if you if you are aware of it, wherein I can address a crime, or address a situation even before that has happened. So those are some of the capabilities that AI is bringing in. Again, thanks to sentiment analysis and topic modeling kind of capabilities within AI. Next topic. So computer vision, I will not go. I think I have discussed it. It's about some of the projects that was done. Was one of with, again, convoluted neural networks for global forest watch. I discussed about that. Then there was a project on plastic detection on ocean. Again, a drone-based CV system which actually detects plastic and spillages in the ocean, and is able to report that, right? So next slide. Generative AI talks about sustainable design. Autodex, a very popular design firm, actually used generative adversarial network GANs, again a very popular model, to do exactly this. Instead of building prototypes, they virtualize that entire aspect of how effectively they can manage, or how effectively they can carry out this experimentation without leading to actual wastage of material and money. right? By building prototypes, testing those prototypes, and all that done virtually with the capability of generative AI, right? So that's an area where it has helped. And again, Google's Genome project, which is also very popular, which was discovering a possibility of crystals, new crystals. When we talk today, one of the problems again is that how effectively do I store my energy? We have probably uh, have some leeway, if I have to say. I don't say we have solved the energy problem, but we have some leeway in energy generation for a perspective, right? But energy is such a thing that it has to be used as soon as I generate it, in case I am not able to store it. So hence comes in the storing layer, which means that I have to bring in batteries equivalent which are able to store my energy. And if I have to bring in batteries equivalent, I need materials which are able to store that energy in a very effective and in a way that it can be stored for substantial amount of time. And therein there are limitations, and that is also a field that is very quickly evolving. And so to do that, there are quite a few designs that needs to be built in, quite a few materials, crystals, etc., that needs to be tried out. So generative AI is actually helping that area in a very impactful way by its ability to create this virtually this material, understand what would be the implications of it, etc., etc. So that's in the research and development field wherein generative AI is helping. So these were the different flavors of AI and how they were tagging back to some of the sustainability goals or objectives that I talked about in my previous slides. So if you can proceed. So again, smart city, I think we talked about it, which is basically again taking my AI to the edge, wherein I am taking my AI to the devices and helping the devices interact helpfully with my ecosystem, so that I need not have any kind of special monitoring, etc. to do it. The device itself is able to help me to a certain extent. So that's where we talk about smart agriculture. Okay, this is an interesting one. John Deere, what it did was about see and spray, which means that most the traditionally had happened for pesticide spraying, right? It was more carpet bombing, if I have to say so, wherein I know that there are some bugs or some insects or something in my field, but I don't specifically know where they are or which area needs to be targeted. Hence, there was an overuse of fertilizers and herbicide use, right? So what John Deere came up with. John Deere again is a very big material, agricultural material producer or manufacturer. What John Deere came about with is this intelligence system, which has the capability to actually scan through the fields. It can be on a drone-driven equipment, or maybe on field equipment, whatever that is, which was able to scan the field and spray herbicide wherever it is required, or whichever area it is required, thereby reducing my herbicide use, which again has a long chain in terms of the sustainability impact that it was creating. So these are also some of the areas again in which AI, combination of AI and IoT, has helped drive sustainability. Next slide, please. So while we have talked about so much good things about AI, right? What is the paradox involved? The paradox involved is that even to build an AI system, I have to use energy and resources, which is again creating a carbon footprint. For example, OpenAI GPT-3 model, not even the latest one, GPT-3, which has around 175 billion parameters, actually needed around 1287 megawatt hour of electricity to train it, right? Which is more than 500 metric tons of carbon. And which, again, to lay some perspective, which is around 116 round trips from New York to Sydney, right? So that is the amount of energy that is required to actually train an ALM model, or let's say for ease of use, to create an LLM model which can be reused somewhere, right? Similarly, the numbers are astonishingly high for even Hugging Face, right? So what we are trying to say here is, while we say that AI is capable of doing this, AI is capable of doing that, it can reduce the sustainability, it can it can do certain analysis, etc., etc. The finer print around that is what is the energy that they are consuming, and hence what is the footprint that they are creating. Hence, when we talk about using AI, and that is my next slide, if you go to that, we have to be very careful about where we are using it and how we are using it. First thing, uh, do I need AI? As of today, if you see, the general tendency is so much AI, 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 that it feels like if I don't talk about AI, if I don't implement AI, is my solution clever enough? Is my solution worth taking to market? But I think we have to really critically think that whether I need AI or not. So I have to see for the touch points what kind of AI I need, what is the AI, what is that I'm trying to deal with, that requires AI. Can it be done without AI? Because if I do it without AI, probably in most probable chances, I will probably have a lesser footprint in terms of my carbon footprint. And if I require AI, then I have to also see that what kind of AI do I use? Do I use a very powerful model to do something that is probably very specific? And hence, if you know, the concept of SLM has came into being when we talk about large language models, more generalistic in nature, more capabilities fused into a model. We have also talked about small language model, which is very specific, right? Which is specific to a use case, specific to an industry, and the advantage of it is the footprint that it creates. It's relatively easier to train. It is relatively less costly for the environment in terms of the energy usage. Next is the kind of computing that I am using. Computing, as my ability to compute has increased, the quality of computation has also increased, which means that how efficient is my computing. With quantum computing on the edge, I think that can take an enormous leap in terms of energy to computing capability, that ratio, which is constantly improving. And the cloud providers today are actually banking on that to bring in the latest and greatest of infrastructure, so that I am able to get the bang for money or energy in a more effective way, which means that if I spend 1 kilowatt hour of energy, the amount of computational power that it's generating has to be maximized, and the graph is ever increasing. So we have to understand what kind of computing that I am using, and preferably I should use a compute that is efficient enough, and hence my carbon footprint is lesser. Third, the amount of accuracy that I require. I can be very accurate. I can use a very perfect model and be very accurate. But is that accuracy required? What is the use case I am dealing with? Am I spilling accuracy or wasting accuracy at the cost of environment and energy and money? Right? But that accuracy is not giving me a required ROI, if I have to say so. Now, this ROI, let's not confuse it with monetary ROI. This is the social ROI, which means that if I am doing, if let's say, if I have to detect something very accurately, I have to detect your location very accurately, right? But you are no threat to the society, or your location, if it is deviating by a meter, I'm just taking a random case, if it's deviating by a couple of meters or tens of meters, it doesn't really hamper the use case, right? Food delivery, for example. Let's say when I talk about food delivery, if I need not be pinpoint specific on where I stay, right? Because if the region is identified, most probably the delivery guy would reach on to you. But to do this, if I have a very specific, very sophisticated model with a very complex footprint, or an aggravated footprint of energy and carbon, etc., to just arrive at that, that might be an overuse. And the example might not be specific. There are other examples as well. But what I'm trying to drive home is that don't try to be very specific when the requirement for the use case is not to be so specific at the cost of environment, energy, and whatnot, right? And finally, building things that are repeatable, right? How effectively can I do things, or how effectively can I design, so that if I design something today, I can reuse that design to a certain extent to do something tomorrow, or I am able to scale that to something so that I can do something greater. So like I don't have to start from scratch and have the entire value chain created, or the entire process created, and hence have a more impact both on money as well as carbon footprint or resource usage, etc. So these are some of the things that we have to take care of when we are talking about employing or using AI responsibility. Next slide. So all said and done, is it just about being good, which means that I have to save the planet, I have to reduce my footprint, I have to save, I have to create a social environment which is sustainable, nice to live, all that things which are nice to do kind of in some perspective. Actually, no. There is a lot of money involved as well, and that is what I just try to capture in this slide. We are looking at around dollar 1.3 trillion of green AI market. All that I have discussed about, right? All of these are going to be very relevant and probably non-negotiable in coming times. And hence, there's a prediction of this much amount of money being pumped into the system or being dedicated for a green AI kind of a situation by 2030, which comes to around 45% CAGR, right? Which I know most of you are very good with finances and would probably appreciate, right? So, okay, what are the kind of roles that I'm looking at? A few with AI, there was new roles that came up, right? For example, you must have heard about prompt engineering, something that came up maybe as new as 1.5 year, 2 years. Suddenly there was prompt engineering, prompt engineering. By the way, I never was able to appreciate prompt engineering so much, which I thought was just about laying out the instruction in a logical way to an AI model, right? But again, there are nuances to it. I don't want to demean that fact, but there are nuances to it. But that's what came up as a new role, if I have to say so, right? Similarly, we can see a few roles coming up from this space as well. One is sustainability data scientist. So how do I use my data, or how do I analyze my data, not from the perspective of how much money I will make, but how much social quotient or social equity that I would create, or ESG equity that I would create. So that kind of data analysis, right, which talks about how much of an impact I am creating vis-a-vis the profit that I am generating, and whether it's okay to create that impact to generate that amount of profit, right, or whether that should be stopped. So those kind of aspects of it, that's a different area in terms of data analysis from a sustainability perspective. Climate AI engineer, very important. Climate, when we were young, right, it was a joke. Like every time they predicted something would happen, that would definitely not happen. They said that there was a storm tonight, and it was nice and cool breeze blew. And they said that okay, tomorrow it would be a sunny day, and the whole match was washed off, right? So people, I don't know if somebody in this group is as old as me. The test matches getting washed off was so normal back then. Not that it is not normal now; it still get washed off, but we get to know. Earlier, what happened was that definitely they will say it's a sunny weather, and the weather would be definitely different from what it used to be. Well, in England, it's even today tricky to predict the weather, but that's okay. So, but this climate engineering is something that is coming up very in a very, what I would say, in a very prominent way, wherein we are trying to predict how the weather would be like, what kind of changes am I anticipating, because there's a lot of involvement, a lot of cost associated with the property, with lives, right? So how do I effectively do that, right? One of the very important things that still we are trying, we are probably just on the surface. It's very difficult to predict an earthquake, but is it impossible to predict an earthquake? Probably no. With this kind of capabilities, we would be able to predict earthquakes, and imagine the impact that it would have. That is one of the challenges current humanity is having, to predict earthquakes, right? Similarly, we talk about analytics in terms of ESG, very correlated to the data scientist example, and obviously green ML ops engineer. When I'm talking about green ML, how do I not only have a machine learning operations which is catering to my business use case, but whether it is catering to my ESG use case, which means the energy consumption that I am doing, etc., etc. So as a group of business leaders, right? Because I am fortunate enough to address probably a group of people who would be future business leaders tomorrow, right? So what are those aspects that you would probably have to look at? Profitability, business, being innovative in your products, all that is aside, that is taken, right? The aspect that we should be very sensitive to is that championing the green AI adoption, right? How am I using? You have to use AI. You have to use AI probably for the next 10 years, but that's for sure. But how do you use AI? What is are you green enough in your AI usage, right? That is something that as a leader you have to be appreciative as well as sensitive about. Similarly, investing in your AI skills, and primarily the term green AI skills, which I talked about, when to use AI, what kind of AI to use, how to limit my usage, how to see what is my footprint if when I am using a certain AI, etc. Right? And finally, talk about people, planet, and profit. We have discussed a lot of profit. We have discussed, or rather, we are very obsessed with profit, right? But the people, planet example, that two parts, how is it actually affecting my profit? It might be a more prudent decision to let go of your profit at the cost of having better impact on planet and people. So those are some of the things that we as business leaders have to be appreciative about, and organization in general has to be appreciative about. So those are some of the things that as a business leader you have to look at. And having said that, responsible AI is something that is very important. The ethical aspects of it is very closely related to the social aspects of it. So how ethically you are using AI, right, is also very important. And that is where the line is blurring, and blurring very fast, with this generative AI and those kind of things coming into picture. And you might all know about this deepfake and all that aspects of it, right? So the guidelines that we set around AI, how do I use it, where to use, what not to use, what kind of guidelines we should maintain, is very important. And having said that, for even climate tech AI startups, we see around 16.3 billion in 2024, 84% rise just for the financial gigs here. There is money. There is money to be made. So yeah, I think I overshot myself. Sorry for that, but we still have 7 minutes. So any questions that you feel you have, I would be happy to at least attempt, if not answer.
Thank you so much for your session, sir. Like, there's one question that popped into my head.
Yeah.
Like, you have told like for easier prompts when we give it to the ChatGPT or any generative AI, there
Mhm.
might be a case in which easier prompts are sent to like very complex models and it should run there. That is
Mhm.
causing more of energy burn or something.
Mhm.
And do you think smaller initiatives like filtering out the prompts before sending it to the
Correct.
bigger models would be something
Right.
helpful in that
Right.
case?
Right. Yeah, so there is this entire agentic AI story, okay, which talks about there is a main LLM and there are submodels. The submodels are models which are energy efficient or less energy hungry. So the kind of prompt that you are giving, right? And the way it works is that when I give a prompt, it responds me back. The algorithm inside it detects whether the answer it has generated is effective or not. For a simple query, there might be answer generated by the local models, if I have to say so, or the less energy hungry models, which is effective and meets your percentage or your correctness score, if I have to say so. Then it's never sent to the backend models, which are power hungry ones. So it depends on the prompt that you are giving and the response it is able to generate. It might be even cached. It can be that prompt, maybe your friend has asked that same question before, and that can be replayed. So I need not traverse the entire length of getting it to the LLM. And that is what agentic AI deals with, where I have a layered approach, right? Wherein either I try to address it with lesser models, or less, I would not say lesser models, or less power hungry models on the with on the system or at the edge or whatever, right? Right. And if it is not effective enough, then I go to the LLM. So that is a technique that is being used both from an efficiency perspective and also your questions around how what kind of footprint it's generated.
Right.
So,
The
sir,
floor is
I had a
open.
question. Uh,
Yeah.
so, since we got to know about the projects by Microsoft and Google and how they were using AI for sustainability, I wanted to ask you, like, do you have any personal experience in your career journey where you found that AI-led sustainability actually made a tangible difference?
Yes, yes. There's one of the I would probably not take the name because of obvious constraints. There is an Indian farm, agricultural farm, right? It's very similar to what has been done for. I talked about the John Deere see and spray case, right? So what we had done here is around the crop yield, right? Now, what is the crop yield depends on various parameters: weather, soil, moisture, etc., etc. So what we had done was that there were some devices which were on-field devices which were able to track the moisture, track the temperature, track the nitrogen content, and those kind of things, right? Those kind of data points through an IoT device, fed it back to the system, and on that system we had this LLM models or the AI models equivalent to detect what is the amount of water that I would use for that particular day. So the way the water was spread, right, or the water was dispersed into the field was driven by the ratings that I am getting at a dynamic level, maybe 1 day, 2 day, or because we don't typical. There are many crops which are not watered every day, right? They're watered at a certain duration of time. Now, what was happening that one, if I water it over, I am wasting water again, going back to my sustainability, and two, I am wasting energy to give that water, which is again causing a sustainability issue. So I have to know what is the right amount of water and when to provide it. That was something that was done for one of the agricultural consulting companies or agricultural advisory companies, if you have to say.
Thank you, sir. That was really insightful.
Are there any further questions? Yeah, so I actually want to share one insight. Like for the climatic prediction that we are doing, for IPL, we have priorly booked some tickets, and then there'll be a lot of arrangements that are happening. And if we predicted further earlier that the match is not going to happen, we can save on a lot of resources to like whatever arrangements are being made and a lot of things. So when it gets more accurate, yeah.
Yeah. Okay. Yeah. Sure. See those. Yeah.
No, I have noticed that it has gotten so much better actually.
Mm,
I have
mm,
booked for one of the show and then one of the match and it did not happen because
mm,
of prediction. And
mm,
and now that I think of it from that perspective, I can see how much of resources might have been saved from
mm.
getting wasted.
Correct.
So
Correct.
that is one of the very major use case of
See,
it.
often the spillover effect is not considered. You are seeing it as buying a ticket and you going there and not able to see the match, right? That's your use case. But look at it from a scale perspective. There are 50,000, 60,000 people going there. What about the carbon footprint of going there? If not, those people would have gone there. So that entire journey has a footprint. What about the switching on of the searchlights, right? If the match was not to happen, they wouldn't have wasted that energy. So as you rightly pointed out, detecting this kind of events is is very critical to reduce my carbon footprint to a large extent. It's not about me paying a ticket, paying a price and not able to watch the match. There are larger ecosystem around it. So we good that you are able to appreciate that. So that's something that
Yeah, thank you. If there are no further questions, we'll close the session. So, on behalf of the Alumni Committee, I would like to extend the heartfelt thanks to you, sir, for
thank you.
taking time to join us on this Sunday and share your rich insights. Your experiences and perspectives on how AI can drive sustainability have truly broadened our understanding and inspired all of us. I would like to also thank Mr. Professor Manish Popli, Chair Alumni Affairs, for his continued guidance and support, and a special thanks to Alumni Office, whose efforts behind the scenes made this talk possible. And of course, a big thank you to our wonderful audience for our active participation and engagement. We look forward to welcoming you again at our next session of Wisdom, the Alumni Talk Series. Thank you so much, sir.
Thank you.